In this tutorial, we're going to answer some binomial questions. So we have this question here. It says, find the term involving x uh, to the power 6 in the expansion that given there. So we must find this. We use the formula n, r, then a, that is n minus r, b, r, where a plus b to the power n. So in this case, our a is this and our b is that, and our n is just 10. So we say 10, then r is the expansion here which we want to get, which is to the 6. So that would be 10, choose 6 like this. Then we have 2x cubed like that, n which is just 10 minus r which is 6. Then I have 1 over x to the power 6. Then this is going to be 10, choose 6 like that. When I subtract that there, I get the power 4. Then that is 1 over x to the power 6. Then this will be 10, choose 6 like that. Then this will be, so 2 to the power 4 gives me 16. Then 3 multiplied by 4 gives me 12. So I have x to the power 12 over x to the power 6, and that just gives me 10, choose 6 to be equal to 16 x to the power 6. So now remember that n, choose r, is equal to n factorial n minus r factorial then r factorial. So this is going to be, this will just be 10 factorial divided by, so 10 minus 6, I get 4 factorial, then 6 factorial. So be 16x to the power 6. Then from here, I can work out that. So I can write my 10 factorial as 10 multiplied by 9, by 8, by 7, and by 6 factorial there. So I have a 6 factorial in the denominator. Then I can write my 4 factorial as 4 by 3 by 2 by 1 by that there. So the 6 factorial divide, and I'll have here I can divide 4 into 4 1, 4 into 8, that is 2. Then 3 into that 1, 3 into 9, that's 3. Then I have 2 into 2 1, 2 into 10, that's 5. Then I just remain with 5 multiplied by 3 multiplied by 2 multiplied by 7. Then this here gives me 210. So 210, then I have this other part which is 16x to the power 6. So here I then multiply this and I just get, so to 10 multiplied by 16, I get 336. So this is going to be equal to 3360x to the power 6. So this is the term involving x to the power 6. So the next question says expand that. So when we're expanding and we have, of course, an exponent, so in this case our question is 1 plus x to the power 2. When the exponent here like this is negative or it's rational, then we will have an expansion of the general form 1 plus nx, so this will be plus n minus 1 over 2 factorial, then x squared, this will be plus n minus 1, n minus 2 divided by 3 factorial, then x cubed plus, then like that it continues to go. So then, meaning the general form of this expansion is when I have 1 plus x. So x in this case, my x in this question is this x over what? Over 2. So I always have to have 1 plus x like that in order to find this, to use this form. So I already have that, so I just replace here. I'll get 1 plus my n is negative 1 in this case, because there it's negative 1. I have negative 1 multiplied my x, that's x over 2, like that, plus, then I'll have my n, negative 1, then negative 1 minus 1 over 2 factorial, then my x squared, so that's going to be x over 2 like this squared, plus negative 1, then I have negative 1 minus 1, then negative 1 minus 2 divided by 3 factorial, then my x cubed is just x over 2 cubed plus, so it continues to go the way there. Then when I expand that, I have 1. Here when I multiply, I'll get negative x over 2. There when I evaluate here in the brackets, negative 1 minus 1, I get negative 2. Negative 2 multiplying by 2, I'll get positive 2. 2 factorial is just 2 by 1, so I get 2 there in the bottom. Then x, so this that is squared, that there, that term, I'll just get x squared over 4. So this is multiplying. Then this is multiplication like that. Then I have here on the next part minus negative 1 minus 1, I get negative 2, and there negative 1 minus 2, I get negative 3. So when this multiplies, negative 2 multiplies with a negative 3, I get positive 6. Then when it multiplies with a negative, I'll get negative 6. So I have negative 6. Then my negative, then 3 factorial is just 3 multiplied by 2 multiplied by 1. So I will get, in that case there, I'll get 6 there. Then I'll get x, that will be cubed, over 2 to the power 3 is just 8. Then plus like that. So this is what I'm going to get. So from here, what I do is I'm going to divide that part, 2 divided by 2. Okay, so 2 divided by 2, let me erase this top part. So I have 2 divided by 2, this is going to be 1 minus x over 2. So 2 divided by 2 is just 1, so meaning I'll just have plus x squared over 4. Then 6 into negative 6, I get negative 1. Then I have this here over 8 plus like that. So they said we end up to the term involving x cubed, which is that last term. So I can write this as 1 minus 1 over 2x, then plus 1 over 4x squared, then minus 1 over 8x cubed plus like that. So this is where I end with the expansion. Now I have my last question here, and it says state the interval of the value of x for which the expansion in C is what is valid. So in general, if I have 1 plus x like this raised to a certain value, let's say negative 1 in this case, I always have to check that this here, this term, is less than 1. So the modulus of that term, so modulus of x has to be less than 1. So in this case, I had 1 plus x over 2, the negative 1. So there I check that this is less than 1. So that term x over 2 must be less than 1. And then here I can write this as half x like that, less than 1. Then this here I can write like that, and x alone like that. Then I'll get 1 over 2 modulus of x less than 1. You can multiply 2 on both sides, and I just get x, this here divides into that, have modulus of x less than 2. And here, having this, by the definition of modulus, then this will just be negative 2 less than x less than 2. So this is what is going to be the valid interval for my x values. Okay, this is the end of this video. If you are new to this channel, remember to subscribe and like this video.